Hello, dear friends. My name is Anton Kanuk. We continue our blog series on theeconomic.com, and today I have a very special guest. I have an honor and pleasure to introduce to you Jeff Doyle. Hello, Jeff.
Hi, Anton. Thanks for inviting me.
Jeff, if you're somehow interested in the industry, dear friend, you might know, well, you definitely should know the name of the Jeff Doyle. One of the biggest book, that was, I think, ever created about routing and stakeholders routing TCP/IP. So everyone who was or is trying to prepare for the CCA exam definitely has read it at least once, perhaps twice. Even myself, I read it twice when I was preparing for C long ago. So, first of all, thank Jeff for creating such an awesome book. The question that I have to you, and then also, right? So it's definitely take a lot of dedication to create the book. How you get the inspiration? How you get the ideas for the books?
Well, on that particular book, the routing TCP/IP, I just really have to admit that it was luck almost as much as anything else. I like most people in the industry, I thought, well, someday I'd love to write a book.
Okay.
I enjoy writing in all of this. This was back in the early 1990s, I thought, well, a good place to start with that is to write articles for different publications. This is back when more industry publications were actually on paper, and I wrote a little article for Cisco World on practical tips for creating access lists. Really simple topic, it seems like. It wasn't so simple back in the 90s. People didn't understand access lists. Maybe and from that, Cisco Press actually contacted me and said, "Would you be interested in writing a book?" And I said, "Yeah." It was a complete surprise to me. And they said, "Well, what do you want to write about?" And at the time, the only book that Cisco Press had published was Bassam Halabi's BGP book, which was one of my favorites at the time. So I was obviously excited and interested in Cisco Press. And so when they said, "What do you want to write about?" I just grabbed the biggest ring I could think of, which was, well, I'll do a general book on routing. And they said, "Sure." And so, it was just the luck of the timing in that, and and I've sort of ridden that to write a few other books, but routing TCP/IP still remains the book that everybody seems to know me from.
Yeah, absolutely, and that is how I was preparing for CCA myself. So I was preparing back 2015, and was what is the materials. Well, not certification guide on the book. Okay, just you need to memorize everything that there is in the book. And I need to admit the book is really awesome. I mean, even 2015, so it's like early or late 90s. So it was like 10 or 12 years old. It was super accurate. Everything that was written was so useful that I really enjoyed reading it, doing the all the lessons. So but the book is big, right? So I think it is about 1,000 pages roughly.
And there's actually two.
Yes, correct. So there are two parts.
Proposed everything as one book and got just a few chapters in, and it was very obvious that I couldn't squeeze that all into a single book, and it turned into 2 volumes.
How many time did you spend on creating these 2 volumes?
Oh gosh, for each one, probably 2 years. And I was a much younger man then. Most of my writing, after I would finish my day job, I would write from about 10 in the evening to maybe 2 in the morning. In most days. And so there's a lot of effort that goes into a book. Anybody that's written a book will tell you the same thing, that, oh, I didn't realize how much work this was going to be. But it was easier then than it is now. I mean, I'm still writing books, but I no longer am very durable for working till 2 in the morning and still being worth anything the next day. So
I could. I see what you mean. Did you ever worry, at the point when you were just thinking, screw it up, I'm so fed up with writing the book that I won't give up, or was it never the case for you?
No, I never felt that way.
Okay.
I've always enjoyed it. I mean, there was a lot of silliness
Hmm.
that happened. The story I love to tell is after that first book, and of course, Cisco Press has obviously evolved tremendously since those days too. But like I said, that was when they were fairly new as publishers. But one of the funniest experiences I had with that was um, finished the book, after all this effort, and they had everything formatted for publication, and I got final PDFs back, and somewhere in there was a person that was supposed to do final reviews for just clarity in the book or whatever, and it was something that I didn't get feedback on until I saw the um, uh, publishing proofs. And they had actually gone in where I was doing cut and pastes from routers and putting it into the book and correcting grammar in
Oh,
the router cut and paste.
that's incredible.
And so there were maybe 2 weeks of very long nights of having to go through everything and and change everything back. It doesn't matter whether this is grammatically correct. It's what the router says, so that's what we've got. And and faxing again, 90s faxing everything back
Mhm.
and forth. But that was an interesting experience. But I don't know, maybe it was learning experience for Cisco Press too.
Yeah, it's really a really nice story, really interesting to understand of the experience. And what you have seen, so since industry, so back in end 90s, beginning of 2000, so what are the most, from your perspective, like building blocks or steps that industry has taken going along the path? I mean, what are the developments that you have observed?
Um, Really, since the time I wrote that book, and which was when I was also getting much more heavily involved in the industry. Um, I think the main shift back then, from mid '90s to maybe 2005, somewhere
Mhm.
in there, where all the exciting things were happening was in the WAN.
Okay.
Things like MPLS, IPv6 was becoming a big issue. Um, well, really evangelizing IPv6. It never seemed to, actually go much beyond that phase. But those kinds of cutting edge things were happening in the WAN. Data centers were really just still traditional collections of switches, arranged in the
Mhm.
traditional three-layer architectures and or three-layer hierarchies, and there just wasn't really much happening in the data center. It seemed like it wasn't that people didn't want things to be happening in the data centers. The technologies just weren't there.
Okay.
That all changed maybe around 2010. I don't want to put that close specific a date on it, but
Mhm.
around that era, we had the advent of
Mhm.
cloud, we had the advent of SDN, and things really started shifting. And nowadays, it seems like aside from SD-WAN, which is just sort of a byproduct of what happened with SDN in the data center, there's not really all that much happening in the WAN, and everything, all the exciting things are happening in the data center. And so that's really the big shift I see. So even things that are, uh, like I mentioned, SD-WAN, things that are happening in the WAN tend to be technologies that are sifting out of the data center. That this is very useful, in our cloud, in our data center, or whatever. And
Mhm.
let's see
Mhm.
how we can apply that into our WAN too. So I think that's just very generally that's what I've seen as um, uh, the difference. And I think the real driver there for those changes is in how the internet is really used. If you look back, the late '90s, I mean, data centers were kind of, sleepy places, and now almost every company, their business really is their data center, and their network. And, and all of us are huge users of things like, streaming video, Netflix and YouTube and, all those kinds of things that, put different dynamics on the data center, and we're driving differences in how data centers are built.
Yeah, I fully agree with it. I also was just saying recently that in MPLS or in the environment world, perhaps one of the technologies that was really something super interesting was segment routing, because it was something different compared to traditional, right?
Yeah, yeah.
And
yeah, and MPLS, I mean, when I was running around, I was with Juniper Networks back in those days, and MPLS was sort of service providers, in those days was Juniper's prime target audience, prime market, sorry. So MPLS was obviously a huge thing there. And I was running around preaching traffic engineering and all these great things that you could do with MPLS. What I've seen since then is that service providers, the ones that were very interested in all these benefits of traffic engineering and all that, since have sort of moved away from that. And there was one big insight from one large service provider at the time, the chief architect there. I made this huge spiel around traffic engineering, and this chief architect just really kind of blew me out of the water by saying, that's all really great, but that's gigantic complexity. If I could build my entire network using just fast, dumb Ethernet switches, I would do it. And that was kind of a prescient insight to me, because that's sort of what's happened, not necessarily with just fast, dumb Ethernet switches, but there's been so much more of a trend of getting the intelligence of the network around the edge, and just having the core of the network, switch as efficiently and as simply as possible, and segment routing is a part of that. That's what kind of sent me off on that tangent there. But segment routing has been a big part of that. It's a much simpler way of doing MPLS, or possibly creating your network without any MPLS at all.
Yeah, and that is another interesting topic that I wanted to ask you, because it's directly going to IPv6. I mean, SRv6 is nice stuff, and we'll touch in a minute. So you said that you was evangelizing IPv6, so back in the days. The experience that I had, I think it was last year, so I was working for one service provider, and I was looking through the RFC, and I remember correctly. So I think it was the last year or the year before. It was, I think it was a year before. In 1998, the RFC for IPv6 was written. So meaning in 2010, it was 20 years since it happened, and it's still perceived by many companies as sort of innovation and a sort of some advanced. What do you think? What is the reason why IPv6 is still thought to be something like not native, not something like authentic, but something like really coming new, cutting edge? What is the reason behind all that?
Expense. Simple CapEx and OpEx. That's the reason network operators avoided it forever. And I agree with you about the dates for the RFC, but I would also mention that people were seeing the need for IPv6 way before that. There were a lot of stopgap measures that were made, and this is sort of ancient history at this point. But people in the late 80s and especially very early 1990s were already seeing that the way IPv4 was allocated and managed just was inefficient, and that it was going to quickly run out. And IPv6 was supposed to be the long-term fix for that, but they also needed a short-term fix. So you had CIDR rules that came out, got away from the, the three classes of IPv4 network allocation, dynamic resource allocation like DHCP and such, and NAT were all created as stopgap measures to help us slow down IPv4 address depletion while IPv6 was being deployed. And everybody ended up just being warm and happy with those stopgap measures, and and it seemed to work, and nobody really cared about the inefficiencies at the time around those measures like NAT, and the such. And so it sort of defeated the purpose for a while of IPv6, and of course that's changing now. And there are still network operators that sort of look at IPv6. Oh, well, they see it as this separate deployment project. When the realities are, IPv6 is really just more of the IP stack now, which is how it should be. And we use IPv6 every day, like, on our cell phones. My provider, I won't name them. I don't know if that's, well, I can name them. I can. T-Mobile is, just, if you're talking on a T-Mobile phone, you're probably talking over IPv6. And that's true for a lot of other service providers, particularly in the mobile industry. But it's out there, and it's very quiet in the background. People are just transitioning to it without even knowing you're transitioning to it. And that is actually something, and sorry, this is sort of old stuff for me, and I didn't mean to turn this into an IPv6 spiel, because I also consider this kind of old hat information. But one of the things I used to talk about with IPv6 transition is that if users are aware of transitioning to IPv6, the transition is a failure. And
that's a nice one.
So that's kind of where we are now. People don't even notice it, really, and I think that's the right way for it to happen.
Okay, I fully agree with you. If customers experience, or if you see that customers see the changes, perhaps I would fully agree with you that something has went wrong with the changes, because it means that something needs to be fixed. Yeah. And that is how it is developing. That I briefly mentioned SRv6. It is also coming to mind the next question. What do you see what would be the next step? So we see that, okay, something interesting is happening right now in SD-WAN, but for the next decade, what do you see would be the most big points for industry challenges? Perhaps what you already see arising in the US market. I know it's a bit advanced compared to Europe. So where we are, or where we'll be really soon?
What I see right now, that I think is just in its infancy, really, is network abstraction, which sounds, in itself, it's like, well, what does that even mean? But it's the idea that we're not dealing with individual elements in our network anymore. We're dealing with this abstracted model of the network, which, huge advantages that underneath are, that we can start building more multi-vendor networks. We start being able to get away from the specifics of, I can only deploy NXOS, or I can only deploy Arista EOS or Cumulus or whatever. We can put all of that in there if we want to. And our abstracted model takes care of the details of actually operating and monitoring those specific devices. So individual network operating systems are beginning to have less importance than they used to. It's still important, you still have to have those capabilities and all of that underneath, but for a network operator, you see less and less of it. And this goes into, what I see as a real bleeding edge trend right now, and I know you had discussions with my friend Jeff Tansura some time back on this, is intent-based networking. You know, if you look at kind of the bottom of that abstraction piece, you know, that's the influence of SDN. You know, we start removing control planes or aspects of the control planes from individual nodes in the network and individual elements, and we centralize that while our elements are still distributed, and it becomes a lot easier to control, you know, all those devices. But above that is IBM, where we now don't have to be tremendously detailed and vendor specific or operating system specific around what we want the network to do. We just tell an intent-based networking system, you know, this is what we want, and the system itself figures out how to do it. And I'm just betting money that Jeff probably said those exact same terms, because those of us that are excited about intent-based networking, you know, that's sort of the elevator pitch on why it's important. As far as going back to the whole abstraction piece, you know, that's not anything really new in the broader term of networking. If you look at orchestration systems and all of that kind of thing, abstracting storage and abstracting compute has been around for you know, ages. And what was missing was being able to abstract the network similarly to that. And you know, and the trend now that's driving all this is to actually do that. So we can do storage, compute, and networking all in one model, and every one of those pieces, those three basic building blocks of our network, particularly our data center, you know, can adapt to whatever it is we express that we want to do. There's a lot beyond that, and I know that when you first contacted me about this, you know, you said, I'd like to talk a little bit about automation.
Yes.
And I think that all of that long-winded spiel that I just made, the reason it's so important is that it all influences automation. And if you look, I mean, automation, again, has been around forever, right? You know, the late 1990s, everybody was talking about Perl scripts and TCL scripts and all those kinds of things that for, you know, being able to more easily control our network devices. But where automation is going now is beyond just configuration management or configuration control. You know, still, when most people think of automation, they think in terms of that. You know, okay, I need to roll out this new feature, or I need to make these particular changes in my network, and I want to be able to automate it so I'm not going around and touching 2,000 different devices. You know, I want some system that I express what I want to do once, and it pushes it out. So, you know, especially, let's see if I can wrap all this in together. You know, I was saying those things about intent. You know, that's the what, expressing here's what I want to do, and the systems roll all that out. But that's only part of where automation needs to be. You know, that's intent fulfillment. You know, I want to do this, go do it. The other piece, though, is intent assurance, which is after I've automated my rollout of this new feature, or, you know, these, whatever those changes are, not necessarily a new feature, just, you know, some specific in my network, I've expressed what my expectations are, my intent. And intent assurance continually monitors the network. It's usually there's closed loop telemetry and all of that to make sure that that intent is continually supported. And again, Jeff Tansura may have talked about this, but one of the problems with modern networks is you can actually get intent drift, where, you know, other changes are happening in your network. So your expressed intent in this area, the network slowly starts not as well supporting what you wanted there. And what you want is an automation system that continually looks at your network and can alert you ahead of time. This is, we're getting this draft. Maybe, if there's enough intelligence in the network, or intelligence in quotes, it can correct itself, and bring everything back into compliance. If it can't, it alerts you ahead of time before things go really bad. In this one aspect, your network is not quite behaving the way we expected it to. And all of that gets wrapped up under intent-based networking. That it's way more. And I think the intent fulfillment is actually probably a minor benefit of intent-based networking. It's intent assurance that it just becomes hugely valuable. It makes a tremendous, does it sound like I'm going into a sales pitch here? I really don't intend for it to be that way. And I can assure you that when I talk about IPv6 or MPLS in the past, I tend to get the same kind of, rah attitude, but because it's something I believe in. But it can be a huge operational savings. And that's really what these days, kind of getting back to what's important in the industry these days, that's what network operators really are up against the wall with, is operational expense, much more than CapEx. And anything they can do to cut OpEx is going to be a huge benefit. So anyway. Was that a long speech or no?
No, that's perfect one, because I think I have experienced it's a part of myself when I was working in one of the previous companies. The biggest ask, or on the one hand, it was the biggest task. On the other hand, it was how to say it, like chocolate for the vendors. So from the vendors to the operators. So look. If you take, at that time it was still, SDN solution, if you take our SDN solution, so you're getting the operational cost savings. But what does it mean? So unfortunately, from what I have seen, and I had, with multiple vendors, quite extensive discussions, when somebody says operational expensive, it quite often goes, it's meaning we potentially could release some people, because people are OpEx, right? So on the other hand, from what I have seen, and at least I have feel myself, so this sort of solution requires, on the other hand, from the people who are supporting them, very different skills, right? Because if something is doing for you, like intent fulfillment, you just say how the network should look like, and some logic is processing your request and implementing, or you say fulfilling the request. It is indeed way, let's say, I wouldn't say weaker, but it doesn't require that much tremendous level of the details knowledge of the protocol stack, right?
Yeah.
However, on the other hand, from what I'm explaining just right now, and what I have seen, on the other hand, for me, I have a feeling that it's more required, despite like Python, right? It's 26 years old. It's getting more and more popular these days. Perhaps it means that for the people who wants to be competitive with the industry, they need to look not only into the network stack, but more for something called DevOps, or something like a bit software programming, software development, just to cope with new systems. New system would still require extensions, right? They would still require some further development in troubleshooting. So what do you think from that perspective, from how the engineers should involve, as a profession, network engineers, with all these technologies like IBM, intent fulfillment, and Intel assurance? What should be the proper career path from what you think or you see from your point?
For the time being, dealing with network operating systems is still going to be around for a while. It's still important to be able to, to know. I think that obviously, I've been an advocate of CCIE for, since,
Yes,
that was
since you are
teaching
CCA, yeah.
in the very early 90s. And that's always a good place to start, just because it's a great program and it's greatly recognized. But I think it's important within your network operating system knowledge to expand beyond just iOS and iOS XE and XOS and all of that. Start learning other operating systems. Junos and Arista EOS and Cumulus, which is a whole different beast, which fun thing about Cumulus is that you're going to have a lot of trouble dealing with it if you don't know Linux.
Yes.
And so that's a natural introduction to what else network operators, network professionals should be doing right now is looking into making sure they understand and are firmly grounded in Linux. Beyond that is of course programmability. Python is the language of choice. Know some Python. You don't have to know. You don't have to be a Python programmer. Like a professional would be, but you need to know enough to be able to use it in network context. And there's lots of books out there, that you can use to study it. But beyond that, I think the focus really needs to be on the ideas of abstracting the network, because in the long run, that's where all the activities are going to move to, is that your entire network, or I should say network, storage, and compute is all one holistic system. And you need to deal with it from that level, above all of that, rather than I'm just a network specialist, and so the development people are going to tell me what to do, or I'm going to tell them what, when you get that conflict there, which is the whole, the result of now the DevOps trend is, operations and development is melding together now, rather than being two traditionally opposing forces. And network specialists need to be sure that they're not getting left out of that. So it's really a matter of understanding the development side of things. Cisco has done a good job, in that area of coming out with a DevNet and and whole new CCIE qualifications around that area. So I think there was another point I was going to make in there. I think I sort of drifted off into that, but I know what it was I was going to say. I think it's important to start understanding things like big data, and big data analysis, because if you look at where networks are right now, especially if you have a large network, you've got a gigantic amount of information that's coming in to your operations. Just this whole cloud of data points. And the question becomes, well, okay, I need all of that data. There's the old saying, there's no such thing as too much information. But if I am wanting to explore one particular answer, if I'm looking for one particular answer, my network is broken, something is broken in my network, and I need to figure out the root cause of that breakage. How do I sort through this gigantic cloud of telemetry to find the exact data points that show what's wrong with my network? And all of that is part of big data analysis. And a lot of that's going to be automated. Again, going back to the whole, abstraction and automation and all of that sort of thing. And by the way, that goes into the whole idea of intent assurance. Also, a good intent-based networking system, should have that kind of analysis in it that helps you sort through this big cloud and say, here's a hint. It looks like this is the place to start looking in your network to find the root cause of whatever your problem is.
Okay, thanks. Really interesting outlook, because it gives exposure. I have a discussion with my colleagues or with some chaps in there on the web, and one of the questions quite often comes, okay, but and actually you have confirmed some of my thoughts that CSA is still valid. I mean, so having solid knowledge with the network stack and protocol is still valid, but it is not enough alone. So you need to have different operation system. You need to know like Python program. You need to know a bit of everything in order to be able to manage current network. And not only this, very interesting about the big data. I have never thought from that perspective. Really, it would be also some fuel for my brain where I start looking after. Yes. Thank you for your time, Jeff. Very much. Really appreciate your time and opportunity to talk to you. To talk to Legend is always is a really really a pleasure from my side. And thank you very much.
Oh, I thoroughly enjoyed it. Thank you for inviting me.
Thank you. Take care, Jeff.
Thank you.